right? And if I let go of the balloon, what's going to happen? Yeah, all of a sudden this balloon gets a lot of motion to it, right? It starts going. But why does the balloon end up moving? Yeah.
Because as it expands, the air fills it, and it's really tight as it expands. And as soon as it's released from your fingers, all the air starts rushing out as soon as it can.
Something move. You kind of want to start from what makes something move. Yeah.
It's because there's this like one little place that the air can come out.
Mm-hmm.
So it's pushing the balloon because it's only coming out of one space, which is it's letting the air out.
Right.
So then the balloon goes the other way because there's nothing holding it down.
Ah, that's a balloon. Right, and what direction is the balloon going to go? Yeah, the balloon's going to go in this direction, yeah, right? Okay, now in order to go in that direction, there has to be some force that's exerted on that balloon, right? So where does that force come from? Well, that's what you're saying there is that the air was being pushed this way. So we had air moving in this direction. Right? So when the air moved in this direction, it pushed the balloon in that direction. Right? So those are the equal and opposite reaction forces. Right? So as you do your rockets, which direction do you want the reaction force to go? Well, you want your rocket to go up, so the reaction force needs to go down, right? So then it's just a matter of, well, how do we create that force going downward that's going to push the rocket upwards? Have some kinetic energy, right? And energy is basically related to force in that if you exert a force, so if we think of this as our force, right? It's a force acting in this direction. If we exert a force over some distance, right? So if you pushed your little brother or sister on a scooter, right? You would push them over some distance, and you would do work on them, right? And that's energy. So that's how energy and force are kind of related. So we need both of those things here. Now, where did the energy come from that created the force that moved this balloon? Where did that energy come from? That energy that we're going to use for your rockets is going to come from applying chemistry. Right? So now we're going to shift over and integrate some chemistry into the physics that we need to make the rocket go up. Right? Everybody following me so far?
Yeah.
What's this stuff called? What state of matter is that in? It's in a solid state. All right? Now in this other beaker I have a candle. All right? What state of matter is the candle in? Solid, good. Now I'm going to light the candle. What sort of vinegar you guys have at home? And again, you guys have probably seen this reaction before. What happens when I put vinegar in baking soda? Oh yeah.
It like kind of explodes.
It bubbles and fizzes, right? Now bubbling and fizzing to a chemist can only mean one thing. Excellent, yes, there's a gas. So when you think of a bubble, the only way a bubble can form is that there's something pushing the liquid out, right? Right. So when you hear bubbling and fizzing, it's a gas being given out. So we're going to get to see solid, liquid, and again, bubbling and fizzing that we were talking about, right? Okay, so it's telling me the gas is being given off.
I want to blow.
But can I see the gas?
No.
Yeah. Oh, yes, you can see the bubbles.
Well, you can see the bubbles that the gas created, but you can't really see the gas. So I'm going to dump a little bit more in there just to make sure I have a decent amount of gas in there. Anybody know what gas we're forming? Well, I've got a little thing that might help us figure it out. You ready? Watching?
Oh man, this is not good.
Really? I'm worried now.
Yeah, this is.
Let's do it. Oh, it's blowing the candle out.
Whoa.
What?
What's
Because there's like air.
Is there gas
I
I
didn't
can actually
see
like
that.
smell and inhale?
I'm going to try try to expand kind of like the balloon, right? But do bottles expand?
No.
Yeah, these are kind of rigid. Yeah, they'll get a little bit tight, so you won't be able to squeeze it like this. And hopefully, before the bottle explodes, the bottom will come out, right? Oh, and when the gases go out the bottom, what happens to the rocket?
It goes the other way.
The challenges when making a bottle rocket is to make sure the cork fits, and it can't be too loose or too tight, so you have to make it just right.
So when we put down our rocket and so it doesn't fall over, we're going to make like a box. So when we put it in there, it won't fall, and so it's not attached to the bottle either, so it doesn't have extra weight on it.
Decided to use the syringes so that we can adjust the height and stick it. If the ground is a little uneven, we can adjust the heights.
So we were using like syringes, but like you told us to use pencils, but the syringes have like a larger top so it can stay easier. And if you're gonna put it like on the set, it's gonna easier stay.
So we decided to put a balloon over the cork because when we tried to use tape, it kept seeping through and the water kept seeping through.
Okay, so we're using these stabilizers and this cardboard piece to make sure that our rocket doesn't fall over before it launches.
I'm gonna show you camera. Wait. Hold up. Just leave it, it's fine, it's fine. Tell me when it's good. It's good, I guess. Okay. Again, okay? Oh! Wait, no, I adjusted it a little bit. Alright, you do it.
Go big! Go big or go!
I know. I read the measurement.
No, that's enough.
I think that our rocket's not going off high enough because it's too heavy.
What? Oh!
Alright guys, we're gonna launch our rocket! And this time, I'm not gonna fail!
I'm not gonna fail.
Don't shake it too much, don't shake it. Shake it.
Shove. He almost wiped out.
It's going!
One of the cork.
Remember, this
Watch out, it's gonna come your way. Oh wait, is it leaking more?
No, don't underestimate it.
Our rocket went higher on the last test because we increased the amount of baking soda.
The scenario for when we launched our rocket was when we had the ratio of 12 teaspoons of vinegar and 2 teaspoons of baking soda.
Which, that is 14.3% baking soda and 85.7 vinegar, which is a lot.
I think the best propulsion for our rocket was the 12-to-2 baking soda vinegar because lots of pressure built up, and considering the size of our rocket, it was the perfect amount to make it go as high as possible.
We had 2 major errors, and the one was like placing the rocket so it wouldn't tip down, and the other one would be measurement and how we should put the vinegar into like the bottom.
To prove the accuracy of our project, we could use technology because it could pour in the right amounts of vinegar and baking soda, and it could also place the rocket perfectly, so then it would shoot up straight.